So let's talk about information hiding. To explain information hiding, I'm going to use an analogy. We're going to talk about a cell phone. To use your cell phone, you don't need to understand how the cell phone works in terms of the electronics, the wireless communication, the digital network backbones that it uses to communicate. None of that matters. All that matters is that you know how to use the phone. Simple things like keeping it charged, how to add accounts to your phone, and how to access the different apps on your phone and how to use those apps. And you can use your phone to do things like watching a video, like the one you're watching right now. You can call, text, and FaceTime your friends and family. You can use social media apps because everyone is just dying to know what you had for breakfast. You can, no, don't do that. Definitely do not do that. All of these things are powered by the phone's operating system, application software, and electronics. Your phone provider isn't going to pop a notification on your phone that says, in order to continue, please explain the 7 layers of the OSI model and how they relate to wireless communication and your phone. Failure to do so will result in termination of your plan. That's why over 5 billion people have cell phones today. The user doesn't need to know how the phone makes a phone call. They just need to know, in order to make a phone call, you need an input, which is the phone number, and the expected output is that the cell phone will then make the phone call and you'll be able to communicate with the person you are calling. That is the idea behind information hiding. We ask the user for a specific set of inputs, then we take those inputs, we process them, and we return to the user an expected value or outcome. In the example of our cell phone, they put in a number and then the phone makes that phone call and connects them to the other person. We don't need to tell the user the process for making that phone call, and they don't need to know. All they need to know what the expected inputs are for the process and what the expected outcome will be for that process. And now that you have an overview of the concept of information hiding, let's take a look at some concrete examples in code. I have the temperature class here that I used in the menu demo program, and it is a good example of using information hiding because if we look at the header file, we can see that I have defined my field. The only field I have is current temperature, and then I've defined the prototypes of my default constructor and my parameterized constructor, and then all the modifiers and the inspectors here, you can see I just have the prototype with a precondition and a postcondition. Precondition tells the programmer what the expected inputs are, and the postcondition tells the programmer, if you give me those expected inputs, here is what the output will be. In this case, as long as current temp is greater than or equal to negative 459.67, it will change current temp. If not, then it's not going to change the current temperature. And then we have our conversions. As long as the precondition is true, that the current temp is greater than this, it will return the correct value of the conversion of Fahrenheit to Celsius. That is a way that we can give a programmer the information they need to implement functions, but they don't need to know how those functions work because we have our implementation file over here, which will be hidden from the programmer. We come over here, we can see here all the functions and the constructors have been defined. They've been written and this is how they work, but a programmer doesn't need to know this is how I'm doing my conversions in order for them to use the functionality of the class. That is a demonstration of information hiding in practice. We'll say this is a simple example of information hiding in practice in C++.